Hello, everyone. This is Professor Ma, and this is the brief lectures on the basic of three-dimensional coordinate system. We'll extend the two-dimensional plane XY coordinate system into 3 dimensions, and by tagging a z-axis vertically out. But there are 2 ways to do this. And over here, I can have a z pointing up and then z pointing down. And if I take the left one and I twist around, and then they all point in the same direction, then this becomes the so-called right-hand systems and the left-hand system. Now, what's a right-hand system? Well, the right-hand system is if I imagine these XY planes on the table, and I want to grab the z-axis, the right-hand system is where your fingers will wrap around the z-axis. So the one on the right-hand side is a right-hand system to grab the z-axis, but the one on the left-hand side is a left-hand system. And in math and science, we use right-hand. In computer science, we use left-hand system. Okay, and we write them as R squared. Here's how we locate points, plot points in 3-dimensional systems. And so in particular, one way to do this is I can leave, first by plotting, leaving the z out of the pictures. So for instance, point A200 is right on the x-axis. And point B, I plot 130 first. That's roughly there. And then I plot the z. Okay, and then that's points you can take a look at it. One thing quite different about the 3-dimensional system is that from the angle that you view things, the things look quite different in orders. In fact, for example, if my eye positions is at location 1, -1, 1, and I have these 3 stripes line up, it looks like that. If I shift my eye position to 1, 1, 1, then that's what's going to look like, those 3 stripes on the ground. If I go underneath and look at from eye position 1, -1, -1, that's what it looks like, the order of the stripes. So think about it, take a look at it. Okay, so the points of this is things looks quite different, left, right, or up and down, depending on your viewpoints. And this is very important in computer science, computer graphics. There are 3 coordinate planes: the XY plane, YZ plane, XZ plane, YZ plane. Okay. In particular, notice the XY plane is defined by the equation z = 0. In fact, let's talk about the basic equations. Okay. In general, if I have the equation x, y, z, and then if I plot the points satisfy the x, y, z equations, what I produce is a surface for a single equation. So for example, suppose I have equation x = 4, and then this is going to be parallel to the yz plane. Okay. Every point on that little blue square have x coordinate equal to 4. Y and z, it doesn't matter. Then that's specified. And here's the y plane, here's the z plane. Okay. So these will call them the coordinate planes. In general, first degree equations, the plot of first degree equations are planes. Like for instance, these are first degree equations. So if I have, instead of just 1 letters, now suppose I have 2 letters in first degree equation, how do I plot these? Well, the way we plot these is first we don't look at the x-axis, we look at the yz plane, and we plot this formula in the yz plane, which is a line. Okay. Now how do we plot that? Very easy. You set y = 0, x 0, and then get a z, then you set x 0, z 0, get the y. So you plot those 2 points, and those 2 points are in the 3-dimensional system. Then notice that since x it's not in the equation, so x can take on any value. So therefore, the surface I'm going to get is this formed by this particular line, slide along in the direction of the missing letters x. Okay. So in other words, that's what's going to look like for these equations. And what happens if I have equation now, I have all three letters there? Well, this is one way to graph it. Alternately, we set two of them to be 0. Okay, so for instance, if I set x, y in the variables in the equation to be 0, I will get z equal to something, and that will be the intercept point on the z-axis. So for example, if I plot these, I set x, y 0, I get z equal to 2, and so I set x, z equal to 0. I can plot these 3 points, okay? And that when you plot these things, when you do this homework or something, you want to take a look at it. Think about how you want to, which viewpoint you want to be, so you get a maximum view. You don't want to plot something which in a plane, but your coordinate system is set up. You're looking at the sideways, which all you see is a line. You don't want to do like that. So therefore, think about how the drawing the coordinate system you want to orient. In this case, these are the 3 points. I put my coordinate system in these manners, and the plane passes through these 3 points. Therefore, the plane must be the plane containing these triangles. And what else are the surface we have? If I given us general equations with a missing variables in general, how do I plot that? Well, first you plot again in the plane with the variables that appear. In this case, plot the formula z equal to x squared. So I'm going to orient my coordinate with x and z, and so I can plot the parabola in such a manner. Okay. And then y is not in here in the equation, so y can take on any value. So meaning that the points on the surface are formed by doing the following: slide this parabola in the directions of y, the letter that's not in the equation. And as I slide, it forms the surface. And this surface is called, in general, it's called general cylinder. General cylinder has a close up, slide somewhere. But this one is open cylinder. What are the equations? This is the equations. This is a formula for distance in 3-dimensional space. And this is the equation for midpoint. The formula for the midpoint, which is the midpoint is, we'll do this coordinate by coordinate. We find the midpoint of 2 points. I want to find out the middle point in space. So I take the x coordinate, average them, take the y coordinate, average them, and so on and so on. And so for example, and here are 2 points, and I want to find the midpoint between A and B. Well, the midpoint is you average all the coordinates. And notice the first 2 coordinates is the midpoint on the plane. The shadow projections of the midpoint, the red point over here, onto the coordinate plane is the midpoint of the shadow entire line in the xy plane. Okay. And this is the equation for sphere. It looks like the 2-dimensional version. And this is the equation for ellipsoids. And just like for 2-dimensional ellipse, I have the horizontal axis. It came from the standard equations. And so this R over here will be the horizontal in the x direction, the radius in the x direction. And the S over here will be the radius in the y direction. And then, of course, there's one more T will be the radius in the 3rd dimension. And so what I want out is say ellipsoid, if they're different. Okay, so here's exercise. So basically, say find the sphere and find what's the highest point on this sphere. So first, I have to find the center of the sphere, which is the average, because these 2 points given the forms a diameter. So first, I find the midpoint. Then I find out half of the diameter using distance, which is 4/2. And I can write on the equations. So what's the highest point? Well, the highest point is take the center, you go straight up the distance of the radius, 3√2. In other words, the highest point is this point. Okay, and that's it. Have a good day and see you next time. Bye-bye. Terminate this structure.